All right, so today what we're going to do is, now I'm just going to throw them all at you. Last week we talked about SSS and SAS. Now we're just going to get them all, okay? So let's go through here. So the first two are ones we've already talked about, SSS. And I just want to draw a quick example of each of these. So SSS would be like this. This side and this side. This side, this side, and this side. Bless you. So that's one way for me to determine if two triangles are congruent. So let me remind you what we did last week. So remember on Thursday of last week, we had those triangles on that paper and we cut them out. And I asked you, before you cut them out, are those two triangles congruent? And one of them I made real close, but it was a little bit off. And when you looked at it, you couldn't really tell. When you cut it out and put it on top of there, you could see, oh yeah, they're not congruent. Well, what we're doing here is we're giving ways to tell, okay, without me having to cut it out, how can I know if those two triangles are congruent? And this is one way, which this one may seem obvious, just side, side, side. If this set of sides is congruent to that side, this set of sides is congruent to this one, and this set is congruent to this one, then these two triangles are exactly the same. Okay? So that's one way we talked about last week. The other way we talked about was side, angle side, SAS. And so that's like this. This side and this side are congruent, this angle, and then this side, and then this side. If that's all I know about those two triangles, that this set of sides is congruent, that these two angles are congruent, and that these two sides are congruent, if that's all I know about them, that's enough for me to know that those two triangles are exactly the same. Okay, so the other ways we're going to talk about today is angle side. Okay, angle side. AAS. All right, so let's draw two triangles here. It would be like this. If this angle is congruent to this angle congruent to this angle, and then this side congruent to this side. That is angle side. And it has to follow that, the A, then the A, then the S. Now what I want you to do is to go ahead, you may have filled that up, but so draw these real small or just fit them in here somewhere. But I'm going to just put another example here just for you to see it a different way. So I could also do it like this. If this angle and this angle, this angle and this angle, and then this side, and then this side. That right there is also an example of angle side. And there's more ways that I could do it, but that gives you two that you can refer back to. Okay, now I forgot to mention, so angle side, another way you can write that is side angle. Just where you flip the letters, AAS, SAA, that's the same thing. Okay, next one is ASA, angle side angle. So it's like this. So if this angle is congruent to this angle, this side congruent to this side, and then this angle congruent to this angle. So angle side angle is kind of like what we did on our warm-up a second ago and what we talked about last week. On side angle side, the angle has to be between the two sides. It has to be the included angle, okay? Over here on angle side angle, the side now has to be the side between the two angles. It couldn't be over here. It's got to be the side between them, basically the included side. All right? So again, let's go ahead and just draw in another example of angle side angle real quick. So it could be like angle side angle. All right, then the last one for these is totally different. It's HL. Okay, HL stands for hypotenuse leg. Hypotenuse leg. And these only work with right triangles. Okay? This only works with right triangles. And we really haven't got into right triangles a lot yet this year. We definitely will, like before Christmas and after Christmas. But the hypotenuse is the longest side of a right triangle, and then the leg is one of the two sides that makes the right angle. So it's like this. So if you have two right triangles, so if the hypotenuse on both of them is congruent, and then if either one of the legs are congruent, then that's enough information for me to know that those two triangles are exactly the same. Okay, now we have SSS, SAS, AAS or SAA, and we have ASA. Now, just as you think about that, you may think of, well, what about the other possibilities? Like, what would be another possibility of using S and A's, of having three of those? Okay, angle, angle, angle is another possibility. And so as you think about these others, that may come into your mind, well, does angle, angle, angle work? And angle, angle, angle is not enough information to prove congruence, okay? It may be congruent if all the angles are congruent, but it may not. So AAA is not enough to show congruence. And I'm going to show you that in just a second, but it's like this. So if you have two triangles where you know this angle and this angle are congruent, this angle and this angle are congruent, and then this angle and this angle. So if this is all I know about these two triangles, is that all three sets of angles are congruent, that's not enough for me to say that these two triangles are exactly the same. And again, we'll do a little thing in a second for you to see that. Okay, so what would be another combination of these S's and A's?
Side angle.
Good. So that's the other one, is side angle, or just like what I did up here with angle, angle, side, you could write side, angle as angle, side, as ASS. Okay? And yes, we were laughing at that whenever I was in high school, okay? And there was probably people 30 years before me who were laughing at that in high school, so fully aware of that. But that makes it easy for you to know which one can I not use. That's the one you don't want to use, okay? Don't be that. Don't use that. So it's like this. All right? So you have side, angle. All right, and just as another example of that, this side, those sides, and these two angles. If that's all I know about those two triangles, that's not enough for me to say that they're congruent to each other. Okay? So what I want to do is I'm not going to prove these two things. I just want to show you an example of both of these so that maybe you'll be able to understand this a little better. Okay, so on that little half sheet of paper that you've got, okay, so on this little half sheet of paper here, looking at the two triangles that are like this, what I want you to do is with your ruler, I want you to measure the length of this side right here in centimeters. Okay, measure this side right here in centimeters. Okay, we're going to try to be as precise as possible here. Okay, so it's a little bit over 7. How many marks above 7 is it?
25.
It's about 3 marks above there. Okay, so if you look, you got 7 right here, and then it's about 1, 2, 3. So it's 7 centimeters and an additional 3 millimeters. So that's 7.3 centimeters. Okay, measure this side on this triangle. How long is that side?
7.3.
It's the same thing, right? So it's 7.3 centimeters. So what's up with these two sides right here? They're congruent. So this side is congruent to this side. Those two are the same length. Okay, next thing I want you to do is measure this side in centimeters. How long is that side? It's about 10.6, 10.7, somewhere around there a little bit. It's kind of halfway between. We'll just go ahead and say it's 10.6 centimeters. Okay? Now measure this side on this triangle right here. How long is that? 10.6, 10.7, somewhere around there. Okay, so what do you notice about these two sides? They are congruent to each other also. That is congruent to that side right there. Now what I want you to do with your protractor is I want you to measure this angle right here. With your protractor, measure that angle right there. Okay, so about how big is that angle right there?
41.
Yeah, it's a little bit more than 40, 41. It's between 41 and 42, somewhere around there. We'll just go ahead and say it's 42. Okay, measure this angle on this triangle. Measure this angle right here. How big is that one? Same thing. It's between 41 and 42. So we'll say it's 42 degrees. Okay, so what do you notice about these two angles right here? They're congruent. So this angle is congruent to this angle right here. Okay, so here's what I want you to notice about what's going on here. We have one set of sides that are congruent, another set of sides that are congruent, and then these two angles that are congruent. So this right here is an example of SSA or ASS, however you want to look at it, okay? Remember, you don't want to be an ASS. That don't work, okay? ASS does not work. Because if you think about it, are these two triangles congruent to each other?
No.
If you were to cut this out, would this triangle match up exactly to that triangle? No way. There's no way they're the same thing, okay? So I'm just showing you, here's an example where you have SSA, and you can clearly see that these two triangles are not congruent. So I'm just showing again that the ASS, SSA is not enough to prove they're congruent to each other. All right, on the back of this paper, what I want you to do on here is I just want you to measure the angles. That's it. So just with your protractor, measure all 6 of these angles. Measure all 6 of those angles. Okay, so how big is this angle right here? 30. I mean, obviously it's an acute angle, so I know I'm dealing with the smaller numbers here, so it's the 30. So this angle right here is 30 degrees. Okay, how big is this angle over here?
30.
It's 30. This is an isosceles triangle. And then how big is this angle up here? Is how big? 120. Okay, down here, how big is this angle right here?
30.
You see, same thing. It's 30 degrees. Okay, measure this one over here. Same thing. You can see that angle's 30 degrees. And I mean, this is going to have to be 120 degrees. Okay, so what do you notice about these two angles right here? They're congruent. So this angle is congruent to this angle. What do you notice about these two angles? They're both 120. Those are both congruent to each other also. All right, yeah, that's a mess. And then what's up with these two angles? They're congruent to each other. And I should have put one for show it's the same as that. But anyways, that gets the point across. Okay, so are these two angles congruent? Are these two angles congruent? Yep, and then these two angles are congruent. Okay, so this right here is an example of angle, angle, angle. These two angles are congruent, these two are congruent, these two are congruent. So angle, 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 but are the two triangles congruent to each other? No, it's very obvious that they're nowhere near being congruent, okay? So again, I'm just showing you here that if all you have is AAA, that's definitely not enough to show that they're congruent. Now, they're definitely similar, but they are not congruent to each other, okay? All right. So let's go ahead and look back to that other one. All right, back over here. So again, what I was doing right there is just showing you why that's true. Just giving you an example of those. All right, so down here on this proof. So number one, how do I know L is the midpoint of WE? Boom, right there. Exactly, because it's given. All right. Now, as I zoom in here and look at this, at what that's talking about, it says L is the midpoint. So L is exactly halfway between W and E. So if L is exactly in the middle of those, what's something that I know from that?
The midpoint.
It's the midpoint. And so what does that tell me about what's going on here?
Congruent.
What's congruent?
W, L, and L, E.
Good. From W to L is going to be the same thing as it is from E to L, right? So I know that this is congruent to this. Those two are congruent to each other. Because that's what a midpoint is. That's what a midpoint does. Cuts a segment in half, making two congruent pieces. So what I'm going to do now is I'm going to write in letters right here what I drew marked over here on this figure. Okay, good. So WL is congruent to EL. And that's true because that's just what a midpoint does. That's the definition of a midpoint. Okay, next thing. It says WR is parallel to ED. How do I know WR is parallel to ED? How do I know WR is parallel to ED? No?
Isn't it because of the lines are up here?
There's nothing on the lines up there. Okay, so y'all are overthinking this. How do I know WR is parallel to ED? How do I know WR is parallel to ED? Not by the picture.
Vertical.
Oh, because of proof.
Because right here, look, right here, boom.
It's given.
It's given. Yes, that's how I know it's given. Okay? I know that's true because it's given right there. Boom. Okay. Now we talked about this. How do I mark or show that two lines are parallel on a picture? How do I know?
Arrow.
Yeah, I'll put the extra set of arrowheads. So let's draw that on here. So this is parallel to this. WR is parallel to ED. Okay, now the next thing they say here is that angle W is congruent to angle E. So angle W is congruent to angle E. Now the reason for this is actually going to go back to our last unit. If those two lines are parallel, these two lines are parallel, what's up with angle W and angle E? Goes back to our last unit.
Side angle side.
Nope, that's this unit. This goes back to our last test, the stuff on our last test. What's up with angle W and angle E?
They're vertical.
Okay, you're getting close, but not exactly. It's in that same type of stuff.
Alternate interior.
Good, there you go. Because they're alternate interior angles of parallel lines, they're always congruent. Okay, and then number 5 now says that angle WLR, that's this angle, is congruent to angle ELD. So, good. How do I know those two are congruent?
Vertical.
Good, because they are vertical angles. Okay? That's the definition of vertical angles. They're congruent to each other. Always congruent. Now, if you'll notice on the 6th line here, what they're saying right here is what we are trying to prove, that triangle WRL is congruent to triangle EDL. So they're saying we have enough information to prove these two triangles are congruent, and we do. So from what we've talked about today, how can I say that those two triangles are congruent now?
Angle side.
Good. By angle, side, angle. Good. By angle, side, angle. That's the way I know those two are congruent. And we're done. Okay, on the back. So on this first one, angle A is congruent to what? To angle D. Angle B is congruent to what? Angle E. And then side BC is congruent to what? To EF. So what I can say now is that by angle side, triangle ABC is congruent to triangle what? DEF. Yep.
Isn't that what it said on the exam?
Yep. Just want you to write this down.
Oh.
Yep. Okay, next one. Angle A is congruent to what? Angle D. Side AB is congruent to side DE. And then angle B is congruent to what?
E.
Angle E. Okay? So now I can say by angle side angle that triangle ABC is congruent to triangle DEF. Alrighty. So let's drop down here. So there's already some stuff marked, but I want to know what extra information is needed to prove they're congruent by the given method there. So up here, there's already two things I know about these two triangles. So what's already marked for us on these two triangles? Okay, so be specific. What's marked congruent right now?
Angle C, angle M.
Good. So angle C is congruent to angle M, and what else?
CB is congruent to
CB is congruent to MP. Okay. So now I want to know, what else do I need to know to be able to use SSS to prove these two are congruent?
AB, MP.
Okay, I need to know that AB is congruent to NP. Now, I want you to write this, but don't draw over here on these because yours is going to turn into a mess. I can erase real easy, okay? So what we just said is that AB is congruent to MP. Is that enough on here to be able to use SSS? No. What else would I have to know?
Angle CA,
AC.
Okay, good. I would have to know that those two are congruent. So I would have to know that AC is congruent to NM. Now, would that be enough to use SSS?
Yes.
Yep, that gives me my three congruent sides. Okay, so now I'm going to erase that, go back to clean slate of where we started. But with the two things still that we started off with. So what else would I need for side angle side?
CA,
Yeah, I would need to know that those two are congruent for SAS.
AC.
So I would need to know that AC is congruent to NM. Would that be enough for SAS? Yep, that gives me my SAS. Okay. Going back to a clean slate of the two things I started off with, what else would I need for angle side?
Angle A and angle N.
Good, I would need to know that these two angles are congruent. So angle A congruent to angle N. And then for angle side angle, what would I have to know?
Angle B and angle P.
I'd have to know that these two are congruent. That way that gives me my angle, side, angle.